Welcome back, guys, to the museum piece restoration, the BVM F100 flight metal covered aircraft. We're continuing in video 4 with the progress. Last video we got the back end done. We started on our flap servos, and we're going to continue working our way forward in this aircraft. So let's dive back in. Oh my gosh, buddy. All right, so flap servos are done. We've finished all that stuff as well. So we do need to run our wiring and everything forward, but I'm pretty sure the next big hurdle I really want to work on is our speed brake. Now, the thing about like the speed brake on my BVM T33, the arms are maybe an inch apart, inch and a quarter kind of thing apart. So it's pretty easy to make a Y out of metal and make those two, actually they're two separate speed brakes, make those things work. Now the thing about the F100 speed brake, if you see here, our actuation pivot arms are like 2.5 inches apart, and we've got 2 air cylinders, and of course it is 1 air brake. So definitely going to be a bit of a challenge, I think, on making this thing servo operated, but I think that is the next thing I want to try and figure out. So I'm going to do some head scratching on this and see what we can come up with. All right, so last video we talked about this, but we got our central box in stock, and we got a couple of our other pieces we needed as well too. So our E4 expander, this is for telemetry expansion. So this plugs into your EXT port as an example, and it has 4 ports on it. So this will have like the compressor, the turbine, the fail-safe, all going to this unit. We've got a high flow vent fitting, the DreamWorks vent fitting, and we have an SE6 expander. The SE6 expander is nice because this plugs into a port, an EX bus programmable port, and you can have either 6 servo ports on this unit functioning, or you can have 5 servo ports and still have your pass-through for port number 6 for what that's being used for. So very cool little unit as well too. So now we've got all of our electronics. So previously we had the plane set up on our test receiver, and what we'll do now is we will get it bound to our primary receiver, and then also bind it to, or plug the primary receiver into the central box. And that's one of my preferred ways to do it, because now it kind of gives us the final steps to getting the electronic stuff set up. And well, you know, you've used a fair bit of jetty equipment over the years when your jetty magnet connection looks like that. So I updated the devices, the Rec 7s, the Rex receivers seem to be coming updated already, but I flashed them anyways. The central box needed an update, so I'm glad I checked that. It's the norm here, we always do that, so you always want to make sure you're updating your devices. So we're going to bind the primary receiver, and then I'll show you guys a little bit of a trick here for getting amps on the central box setup. And what this relates to is when we were talking about our servos back here, when we get those amp outputs, we can get these servos programmed, and we can actually see the current draw on the central box and the radio of what's plugged in. So we'll be able to see spikes in the amperage with those 2 servos. All right, so we are just going to pair our primary module. All right, so that's paired. And then next thing I do is I just go into the Rec 7 and just make sure that everything is set up like we want it to be. So we'll go Device Explorer, Rec 7, and then just go through our settings here. So some of the specific things that we're looking at, so general settings, output period, we basically always set it to 11. Alarm voltage in this case, because we're going to be using a 3-cell LiPo into the central box, we will be outputting 8.4 volts all the time. So I'll just put my low voltage alarm at 7 volts, that's fine. Fail safe, that's going to be done in the central box, so we want to disable on the receiver. Alternative pin configuration, so we want to do our, for now, we want to do E1 as EX bus, E2 as EX bus. That's probably how it's going to stay on this, because we'll plug our clone or our second receiver into the central box. So we'll leave that as is. Receiver outputs, nothing to change here. Now what we'll do is we'll unplug this. So now what's going to happen is we'll be going through our central box. So that's pretty much going to be the standard now for everything we set up. So we're going to go R1 there into E1 on our primary receiver. Now you don't need to hook a switch or anything up to the central box to make it work. All you need to do is take a bind plug and plug that into the switch port, and that now temporarily operates as our switch. Long term in the aircraft, we'll be using a remote switch to do on off from the radio, but this allows us to get the central box working and allow us to get all of our servos set up. So we've got a LiPo plugged into the 310 now. Nothing's on yet, so if we pull this out, now everything's going to work in the radio. So low voltage, and the reason for that is the central box comes standard as outputting 5.45 volts. So we want to go into our central box and get things set up there now. So we'll go menu, system, model, device explorer, central box 310. And we're going to just go through each of our menus here. So we'll go to general settings first, output period, 11, and then this is all of our ports. So we've got E1, E2, E3, E4. So those are all of our programmable ports, so we can set those up as EX bus, receiver, or whatever we want. Same thing there. We've got S bus output is the only difference. E3 just goes down to EX bus, and then we've got E4 there. So those are done. Receiver inputs, it's automatically picking that up as well too. Switch over strategy, we'll leave that. Output voltage, so let's go up to 7, we'll just go to 8 volts, so it's putting direct LiPo through right now. So now our warning disappears and we can turn our volume back up. So that is everything for the first screen. Second screen, we're going to leave this probably as it is, nothing to change in there. Fail safe for now, we'll leave that as is. Output mapping, we're going to leave the stock setup in the output mapping. Telemetry, we'll leave that as it is right now. And telemetry min max, we're going to leave that as it is right now. So a couple things you can do here. So clear max min values. One thing I like to do here is put my volume all the way down at the bottom. So I always use P8 as my volume switch. So when we go volume all the way down, that automatically resets everything. So we'll just set that up. And that's now done. So every time we go down to the bottom, it resets all the telemetry data for the central box. So that is the CB. Now let's go into our amperage that I was talking about. So what we want to do is we want to change the clock to be amperage of the central box. One key when you're doing this is you only want to have one battery plugged in. So let's get the clock changed out now. I'll show you guys how to do that. So we go menu, timers, sensors, you go to main screen, and we're going to go to the telemetry displayed at clock panel. So we're going to take that out. We're going to go to telemetry, and we're going to go to CB 310 amps. There we go. So what we're displaying here now is the amperage that's being drawn by the central box. So our receiver and everything that's operating right now, which is nothing, is taking 0.1 amps. Now if we take one of our old servos and plug that in, we'll just go into port. I don't know what ports are described here, but there we go. So that's aileron port. So we have got one of these 8411s plugged in here, and if we go like this, you can see the amperage rise to 0.8, 0.71, whatever it is. So this is great because when we set up those tail servos now for the horizontal stab, what happens is we can go to our ends and we can dial and match those servos so we get the lowest amperage draw on these servos. This is also a helpful setup tool for just generally anything on the setup of the aircraft. So as an example, if we take this servo and stall it out and keeping an eye on that amperage screen, you'll see the amperage climbs up. We're over 1 right now, right? So if you've got binding on your servo, that's going to show up as an increased amperage number on the radio. Very handy little tool. And it's been a minute, guys, since we've had a tip time. So I think that definitely qualifies as a Jetty tip time. And this tip time has been brought to you by Trusty, the original Trusty, because we got our apron back on. Trusty bent screwdriver. All right, guys, we are picking the winner now of the turbine install kit from RC Custom 3D Printing. And yeah, let's do this. So this is randomly from the comments in video number 2 in the series of the F100. And in order to win this, you had to make a comment using the word AMT. So I'm going to flip you around and we'll pick a winner from the comments at random. So we're using our TubeBuddy program here. So pick a winner from comments must contain the words AMT, and let's do it. Oh, the winner is Chad Carr, 3338. Congratulations, Chad. I know where you live, so don't tell me again that you never win anything on the channel. So congratulations. Thank you guys for supporting the channel. We've got so many cool giveaways coming, so stay tuned. And don't forget about the UAT giveaway, which was in Saturday's video that just passed on the Rebel Hot. So keep an eye out for that. We got tons of stuff coming up. So one of the very important things with our planning here is where the heck are we going to put this central box 310? I need to know this before we continue. So we've talked about this already, but our tanks are sitting here. We probably have our UAT sitting down there. I'm not entirely sure yet where we are going to put the Cortex. That's an important one as well too. But we can kind of fit that in wherever is needed. But I'm thinking we can put the central box there. The nice thing about that too is we still kind of have reasonable access to it if needed. So yeah, I think that is probably a really good spot for it. I got to be careful how much we bump it out, because if I bump it out and make mounts, that gets really close to the ducting. So those are some of the critical things to be aware of. We could also drop it down further too, because we don't really need access to it. I mean, we don't have good access to it there anyways. So if we drop it all the way to the bottom, we have way more room down there because we've got room underneath the duct. So maybe we'll do that. That's probably a wiser decision. Okay, so we know where the 310's going. That's good. As far as Cortex goes, I don't know, because we've got our pilots sitting here. We've got this guy sitting, oh, that guy sits there. Okay. So that we'll have to figure out. Cortex could mount up here, but again, we don't need access to it. You know, lots of the planes we do hidden installations, so we can hide that somewhere else as well too. So yes, yes. All right, so that definitely makes me feel better about that 300 series. I was actually really worried, guys, that we would have nowhere to stuff that thing, but we do have a good spot for it. So, all right, so now we're getting into our air brake. Still don't know what I'm doing yet. So I got one of the air cylinders out here. I'm really struggling with thinking that we can make this work, but I'm gonna see. We've got 60 millimeters of movement here on the air cylinder. So that's basically what we need to shoot for with our servo movement, which is for you Imperial folk, is about 2.5 inches, I think. Yeah, 2 3/8. So one of the primary issues we have with using a servo in this area is the fuel tank. So these supports down here, these guys, and there's one right there, they are what the fuel tank sits on top of. So that is definitely a problem, because that is right where we need to do things. So actually our clearance goes down substantially because the fuel tank sits down here. So still don't know if we can make this work, but I'm trying. All right guys, and I think we need to scrap the idea of using a servo on this guy. I was just taking this rod here and just doing some mock-ups, so I'll give you an idea. So we would need to be sort of in that area, and then like the amount of travel needed is crazy. I don't think we can get that travel without interfering with the tank. So we would need a very long servo arm to get that travel, and that servo arm is going to sit up and it's going to interfere with the tank. So in order to get that amount of travel out of this, yeah, it's just not going to work. So, and the other downside too is when you're at fully retracted, the geometry here is terrible for a servo. So this air brake could conceivably just drop most of the way out, because there's like zero mechanical advantage there when this is closed, because we would need to be all the way back. So yeah, unfortunately with this aircraft, there is no good way, and I even thought about using 2 separate servos, but there's no good way to get this guy working. All right, so now that we know that we're using our air cylinders for the air brake, we're just going to leave those guys in place. We need to service all of the air cylinders on the aircraft as well too, so we'll get back to that in a minute. I just want to get our lights pulled off here and get things cleaned up. So we are taking out the existing air-powered drop-down lights, and we need to see if we can fit in the, well, we need to fit in the Unilight drop-down lights. So fortunately, I think this stuff was glued on with something, not epoxy, which I'm very happy with, because we're able just to kind of peel these things off with a fair bit of force. Undid the steering servo as well too, so we'll get to that. We're going to pull the front gear out as well, and that's the process. So kind of just have to get things cleaned up for the final amount. So once we get these light cylinders out, I think we're probably going to work on taking this stuff out as well too, because that's not going to be needed there. I think this is where the hopper tank was before. So just being a little meticulous with this, but that's what we're working on next. All right, so working on the lights now. We took the pivot off of this guy and disconnected the ring. The ring was just, again, glued on with kind of that rubbery type glue. It's almost like clear or white hobby glue type stuff, so, or canopy glue. So anyways, our just getting the lights lined up here for the drop-down lights. Now, it looks like they're both going to fit in there fairly well. Because the servo sits off in this direction, we'll need to do a little bit of trimming on the wood piece right there to fit this side in. But the Unilight drop-down lights are pretty slick units for this aircraft. So the actual mechanism and the base plate are separate right now, but here's a shot of what they look like. So servo operated, of course, and drops down like that. So the nice thing is it's very low interference with the whole arm and pivot design, so it's a pretty slick unit. And the other thing I did was I took the original LED, which had this guy attached, the scale piece, and took that off. The hopes here is to reuse this scale piece. Now, because our pivots are different and everything, really likely we're going to have to get rid of that section right there, because when this light drops down, we don't have enough space for that portion, which I don't think is going to be a big deal, but overall the size of this light compared to the original light and this housing piece is perfection. So that's going to make for a nice scale finish. And this, once we get into working on the underside here, we will flip this aircraft over. But our plastic piece on the inside is that flange that's there, and then this allows a kind of a recess to sit against the flange and the skin. So it's going to be a really nice finish. And I did check already, I'll grab the light and show you guys, that the light actually fits and comes out here. So let me grab that light and I'll show you what it looks like to drop it down. So I need to get this lined up, but I'm going to get it relatively centered, and there it is, dropped down. So it's going to work, I think, really well in that scenario, and I think it's a great fit for this aircraft. And then you can see on this other side why we need to do a little bit of trimming there, so just to make room for the servo to sit right in this location. The nice thing is I was worried that these wouldn't fit initially, but the servo actually doesn't interfere with the door opening at all. It's just shy of the center of the hinge line. So I think that is all going to work out great. So we're going to do the same modifications to this side. While we've got that out, we'll pull all of our wood out and everything, and we'll get this area cleaned up and ready to take care of our servo and light combo. And the other thing we're working on right now, focusing on that center section, is our tanks. So we're kind of flipping back and forth between the lights and the tanks. I just wanted to take a look at the tank, see what the inside looks like. So there is a baffle in this tank. Here's the clunk that was in the tank. So severely undersized clunk for number one, that Olympus that was in there, and number two, the turbine that we're putting in here. So this is all 6mm Festo line. So what does that mean? That means we need to change our clunk line and bung fitting and our vent line. So we're gonna have to do a little bit of destruction on these tanks and find a suitable fitting or unit that plugs in there and works with our scenario. Now I am plumbing these tanks in series. So what does that mean? That means that our UAT is sitting here. When we're filling the UAT, the fluid's gonna come out of the UAT, go into this tank, fill up the tank, come out the vent, come to this pull line right here, fill up the tank, and go out the vent of the aircraft. So as this airplane uses fuel, it's going to use this tank first. And the benefit of that is when this tank pulls air, which is always going to happen a little bit, when this tank pulls air, it's pulling that air into this tank, but this tank is going to have fuel in it for a long time. So it's going to drain this tank first 100%, and then it starts to pull from this tank. So it's just a more reliable setup with this type of fueling system. And these tanks are so close to the center line of the aircraft that you're not going to notice any lateral balance difference when one tank is completely empty and one tank is full. All right, I'll share my success here with the tanks. The vent fitting, able just to pull those out, no problem. You just untwist them and they thread out. The fitting inside the tank. Now those fittings originally are flanged. With the BVM kits, you install them from the back side before you glue those tanks together. So this is what the fitting looks like. So that was glued in like that. So obviously you can't just remove this. So what I did was put a drill bit that's a little bit bigger than the threads and drilled that out. Now when I drilled that out, all I was trying to do was unspin this thing and push it inside the tank, which I did. Then I took a step drill bit and we drilled this out. And I drilled it out not thinking about what fitting we were going to use in there. Step number one is just getting this fitting out. So we drilled it out enough so we could pop this fitting out, which we did. And then, fortunately, the DreamWorks high flow fittings are the perfect replacement size. So that worked out wonderfully. And this is our new vent fitting. So we'll have to drill that guy out as well too. But that is going to be our new setup, which of course is perfect for a high flow setup. So that's what we're going to be installing. So this tank is drilled out and obviously the bungs removed. Need to do the other tank right now. All right, so we got our tanks set up and prepped and ready to go. I need to do a little bit of sanding around the edge, but otherwise they are all, fittings are installed, ready to go. I'm gonna rinse these tanks out with alcohol first. just to make sure that any of our pieces, our big pieces, are out. And it's going to be easier to rinse them out now without the bung in there instead of later on. So, but we're going to do a little bit of sanding around these openings first with a Dremel, just to give the epoxy something to bite to, and then we'll get these guys glued in and set up and curing. All right, so tanks are prepped and ready to go. Rinsed them out twice as well. There was a lot of big hunks in there, so it was important to get that stuff out. So we're going to be using Loctite 9462 for critical joints like this. So all we're going to do is mix them up, get these guys installed, and we will, on the bungs here, I'll tape those in place. These guys are threaded in, but we'll tape those in place and we'll let them cure till tomorrow. All right, tanks are all glued and we're just going to leave those sit till tomorrow. We're keeping the bung fittings and pickup fittings just so we can use those for dimensions. We won't be reusing any of that stuff though. Our center pipe, we are going to be installing a new pipe because we need a high flow version, new clunk, new everything. So, but we'll keep those till we're done with them. So moving on to the lights here, you can see how they soldered the black piece that the light mounts to and onto the arms here. So basically there's connections built in here to the pieces. So you could use high sol and glue this together, or I guess CA as well, but the easier thing to do, or maybe the easier thing maintenance wise, is to use solder in these four corners. And then what happens is if you ever need to get those guys out, the plate can stay glued in place and you just unsolder these pieces. So I'm assuming that's what the intention is, but anyways, we'll fire up the soldering iron and we'll get those guys glued in place or soldered in place as the next step. So we've got our lights soldered together. So those are all ready to go. Just kind of moving on back and forth between things now. I have made the decision though to run the lights at 3-cell LiPo. The reason for that is it's just going to jive with our system better. Now, most of the Unilite lights you can run either 2-cell LiPo or 3-cell LiPo. The determining factor, when you look at the labels, you'll see they will have it listed as 2S and 3S. Now, they do make some lights that are only 2S. So most of them though are dual voltage. Now, if you're running them at 3-cell LiPo, you need to include the additional resistor in the power system feeding the lights. So we'll do that for each of the lights, and that's just going to make things jive a little bit easier with everything. Now, reason for that is because we are using the Central Box 310, as we've talked about, there's going to be 3-cell LiPos powering the central box, and the central box reduces the voltage down to whatever we set it at, so 8.4 volts. And those batteries, those flight batteries, can also power our other things like our lighting system, like the compressor, and it's just going to make for a very simple installation on this aircraft, battery-wise, because we can use 3-cell 4,000 milliamp LiPos and just drop 3 in. One's for turbine, 2 is for everything else. So makes it very simple. All right, working on steering servo now. So the steering servo that came out of here is this lovely, I don't even know what that is, JR Ness 911. It's a plastic arm servo. So the 1220 that's going in here is a little bit wider, but the dimensions are very similar. It's a little bit wider this way and this way, but shouldn't be a problem. We'll take our other hardware off of here, that's not needed, but the servo setup is fairly simple. All right, new servo is mounted. So we've got the NKS HV 1220 servo. This is our kind of common steering servo. We pulled the other stuff off of here, so there was a little wood extension with some blind nuts and stuff, but all that's just for the previous install. So again, stripping that down to nothing. And we need to figure out our servo arm for this. Now it's a double arm and it's a cable setup. So we want to match what's in there just to make this a fairly straightforward transition. But what we're going to do is we're going to flip the fuselage upside down and we're going to pull this nose gear out and get that all Loctited, serviced and 100% before we put that back in, and then get the steering servo set up. So that's all part of the reconditioning. And then we've also got the nose door actuator here as well too. So same thing as our other ones, we want to get those serviced as well. So we're going to strip all that stuff out and service it. All right, so taking this front gear out, undid the little cable that attaches the nose door. So that is out. And took off the screws, the 6/32 screws holding the gear out, and we should just be able to pop that right out. Yes, so perfect. So some cool scale details on this old front nose gear. Just some, I mean, for the time, pretty neat stuff. Some tubes and hoses and such. So what we want to do in this case is we want to make sure we're happy with everything and how it's actuating. So, you know, most of the stuff's good the way it is, but we want to lubricate our O-rings in our cylinder. We want to make sure that we're Loctited on our fasteners here and everything is jiving and good. Definitely an interesting setup here. You can see how the arm turns and everything. Kind of unique for sure. We'll go through everything else too. We'll clean this up. Probably take that shaft right out and clean that nose spring up, because the grease or whatever was in there is very, very hard. So it's basically stripping it down, putting it back together. All right, so gear's all serviced, everything's moving very nicely. What I do to get some silicone oil inside of our cylinder here is, while I'm moving the cylinder, I take a little bottle of silicone oil and just hold it over the nipple. And as the suction side, so for example, as we're moving it this way, it's going to suck air or oil inside this nipple. As we're moving it this way, it's going to suck it in that nipple. So we've got some maybe 5-6 drops of silicone oil inside that cylinder. And then we've got the gear all cleaned up, lubricated the shaft and pivot and everything there, and it works beautifully. Cleaned up the shaft, cleaned up the wheels, and they're all spinning and working wonderfully. So Loctited everything as well too. So this is ready to go back in, but we're going to just leave that aside while we get the other detail work done. So previously, this fake red flasher was on the underside here. So we just popped that off. That was glued in place. And we are installing our scale light. So we opened up the hole here for the Unilight. And this is the beacon that fits on the underside. So open that hole up enough to make that fit. And then we do need to extend this a little bit because our wire comes off the end. So we do need to make that shaped like the light itself, but wanted to get that hole done first. And then this is the lens that goes over top of that. So it won't just be a scale light anymore, it'll be scale and functional. So pulled the cylinder out for the front nose door. And now that everything is out of the front nose door section, we are going to work on getting our lights completed. So we can get the drop down lights done, the little red beacon on the bottom done. And the reason I took all the gear stuff out is because if we have to do any sanding or grinding in here, we don't want to have that gear sitting in here with the possibility of ingesting any dust. So that's why we're doing things in this sequence. So we're going to get our resistors added first to our various lights. So we've got these two to install on our drop down lights and this guy to install on our beacon for the underside. So pretty straightforward. What I do, it doesn't really matter where these go, but I just install them on the orange line, the positive line, and you just install them really anywhere in the line, but I'll just put it right here after the existing resistor that's already in there. All right, so that's what it looks like when you put the resistor in there. So I just do a little loop on each side of the resistor and put the wire in there, solder it in, and we'll put the heat shrink over top of it. All right, so I think the next thing to do is to play around with these guys and see how they work. We want to do that before we put them in the airplane. So I'm going to get the controller kind of mocked up here. We'll get some batteries and stuff set up and see about getting that controller plugged in and playing around with these lights. All right, so lots of fun times with this programmer. It's actually quite simple and intuitive. So anyways, this is the programmer for the Eco 8 system here. So right now we've got it plugged into the radio. We've got one channel hooked up. We only have 7.4 volts going through it, but here's a shot of the lights and the servos and everything. So That obviously is servos out or lights out of the fuselage and on. And then we've got a nice servo delay and light delay put on there, so they retract. And then if we do activate the light coming out, so out. Very cool. So all that, of course, is programmable in the unit. You just have to play around with it and see what's best. But pretty cool setup. I'm happy with this. So we've got that figured out. Obviously, when you do the changes in here, you save it, and that's saved in the light controller. So right now, we can unplug the light controller from the computer, and all of this is going to happen normally. So let's try that. So we'll disconnect. Yes. Pull that out. And you do need a specific cable from Unilight as well, the data cable. And then we'll try it. There we go. So we've only got this set up on a 2-position switch right now. So essentially lights off and then lights on right there. So you do have the opportunity as well too to make a position number 2 in the lighting controller. So essentially you can have a 1 position, which is, let's say, off. You can have a 2 position, then you can have a position number 3, which could be gear down and whatnot. So what I'll actually go in and do is I'm going to go in and I'm gonna set up profile number 2, so we have that option later on, and then you have to get to profile number 3 in order for these lights to drop down and turn on. So I'll show you guys what we do there to do that. So we're going to go into the Economy 8 controller, full settings. We take the unit here, plug it into the data port, and then we just hit connect, and that pulls up all of the stuff. So if we go to servos as an example, so if you go into the controller here, you can see right now we're physically on scheme number 3, but scheme number 1 is the program port here right now. So if I go like this, there we go, now we're in scheme number 1. So if we go here, we also have the opportunity to pick scheme number 2. So scheme number 2 we can set up, and scheme number 2 we can have it set up as lights off, lights retracted. So these things stay in until we're in scheme number 3. All right, so we've got our drop-down lights both tacked in place with some CA. Once we're happy with those and everything, we're going to probably put some aero epoxy on the base plates. And we're going to flip this fuselage over right now and take a look from the underside. And then also, while we've got the fuselage flipped over, we're going to install our other red beacon on the underside as well. All right, so we got our beacon installed, we've got our drop-down lights installed, and I think they look pretty good. We were able to keep some of the elements of the original install. So the I don't know what you call it, the trim piece here, I had to cut that portion off because we would be left with so little amount in order to make this setup work. I did keep the base piece and just glued it on the black plate of the light itself, and there we go. So I think they're going to turn out wonderful. So what I'll do now is I'm going to flip this plane back over. We'll get both of our drop-down lights installed and our beacon, and we'll see how those things look. All right, so we just have the fuselage on its side just so we don't have doors and stuff interfering here. But so right now the lights are in the off condition, condition 1. If I go to condition 3, they drop down and everything turns on. This is only on 2-cell LiPo right now, so it will be brighter on 3-cell, but super cool. Really nice. And then we'll retract them. Awesome. All right, guys, that's going to wrap up video number 4 in the BVM F100 museum piece refit video. Let me turn those off so it's not so crazy. Very happy with the progress so far. I'm trying to keep these videos fairly reasonable in length, but we are making some wicked progress with this thing. Obviously I'm trying to keep them detailed as well too, so there's a lot of little things to deal with on this plane. Congratulations to the winner of the install kit. We haven't done the draw yet for the install kit when I'm recording this, but I'm going to do the draw and put it in the video at some point. So congratulations to the owner. Make sure you reach out to me at thelightersideofrc@gmail.com, or the winner, I should say. Encourage you guys to check out the Lighter Side of RC After Dark. It's our live channel. We do live streams here from the shop, usually every second Saturday. It's tons of fun. And also, we've got a podcast, the RC Air Experience. Me and my friend Anthony do a podcast. We had Bert Garrison on as our last guest, and Bert was the SR-71, the final SR-71 pilot, also has flown the U-2 plane. What a phenomenal guy. And we've had Martin Pickering on, and just a plethora of amazing guests, and it's been tons of fun. So there's links down below in the video description. Check out the RC Air Experience, and it's a good time if you're into podcasts and stuff. So that's it, guys. Thank you so much for watching the video series, and we'll see you in the next video.